Good afternoon, chemists. I'm hoping you can help me solve a slight issue I've got with an over-concentrated glass of orange juice. I need to figure out how I can get this glass of orange juice, which is half and half concentrate and water, into a more tasty concentration. So I've drawn a little diagram of the problem here. We've got 250 mils of water and 250 mils of orange juice, which have given a concentration of 1 ml of orange juice for every 2 milliliter of the total solution. And we want to get this into a concentration that's more in line with the 1 to 10 that's described on the back of the orange juice bottle. Okay, so we're going to look at how we can figure this one out from a chemistry point of view. So we already know that the number of moles in a solution is equal to the concentration times the volume of that solution. Okay? And in this case, the number of moles of orange juice in the final glass is going to be the same as the number of moles of orange juice taken from the original glass. So let's just recap on that. The number of moles of orange juice in the final glass will be the same as the number of moles of orange juice taken from the original glass. So if I write this problem down in this respect, we're going to take a quantity, a volume from the first glass and put it in to that second glass. Okay, so I want to know how much or what volume of solution 1 I need to make a tasty 500 milliliter glass of solution 2. And the key thing that we've just pointed out there is that the same number of moles are going to be taken from solution 1 and put into solution 2. Okay? So if we know that the number of moles in solution 1 is equal to the number of moles in solution 2, and we know that the number of moles in 1 is equal to the concentration of 1 times the volume of 1, and that the number of moles in 2 is equal to the concentration in 2 times the volume in 2, we can therefore work out that the concentration of 1 times the volume of 1 is equal to the concentration of 2 times the volume of 2. Okay, so we're going to use this to figure out how much volume of 1 I need to take from the first glass into the second glass. So what do we know about the volume of 2? We know that the volume of 2 that we're going to be left with is going to be 500 milliliters. And we know that the concentration of 2 is going to be the same concentration that's recommended on the bottle, so that's going to be 1 in 10. We know that the concentration in 1 was 1 in 2. We can just note down that that's a concentration of 2 as well. But we want to know what is the volume of 1 that we're going to take from glass 1 and put into glass 2. So what is the volume of 1 there? Excellent. So if we think about making a calculation of, based on our C1 V1 equals C2 V2, we can substitute in what we know already, that the concentration is 1/2, volume of 1 is what we want to find, concentration of 2 is 1/10, and the volume of 2 is 500 millilitres. And we can rearrange to get 2/10 times 500 millilitres, which gives us 100 millilitres. So we know that we need to put 100 millilitres from 1 into 2. So that's 100 millilitres from number 1. And then we're going to top up the rest, 400 millilitres, with water. And we should have a nice tasty 500 millilitres of 2 in a concentration which equals 1/10. So I'm just going to do this now and double check to make sure that we get the nice tasty drink that we want. So I'm going to carefully try and pour that in to 100 millilitres. There we go, a little bit of splash, never mind. And I'm then going to pour in, top up to 500 millilitres of water. There we go. Pour that into my glass. And I'll do the final taste test. Delicious. Thanks for helping me out, folks. Cheerio.